Up to this point, we've been talking about exponential and logarithmic functions, but in this specific video, we're going to be focusing on the applications. So logarithm and exponential functions are used in the real world, but again, in this video, we're just going to be focusing specifically on one certain type of application, which is the financial applications. There's some formulas that are used in the financial world that are actually exponential equations, and we're going to be talking about two of them today. So these are the two different formulas that you are going to have to know for this section. The first one is called the compounding formula. It is going to look pretty scary, but again, we're going to do a bunch of problems together. So the first one is compounding formula, and the equation reads as follows. It's going to be A equals P times 1 plus R over N to the power of NT. Of course, in order to use this formula, you do have to know the meaning of all the variables. So this is what the variables mean. A in this problem is going to present how much money you have after your investment. So again, this formula is going to help you understand if I invest a certain amount of money, how much am I going to have afterwards? So A is going to stand for the amount after. P starts for your principal amount, which is how much money you start with. The 1, of course, is just a 1. The R in this formula is going to represent your rate. Just make sure that you read this. It has to be the rate as a decimal. So if the problem gives you the rate as a percent, you are going to have to convert it to a decimal. N is a tricky one here. N is the amount of times compounded, and I'll go more into depth about that in a little bit. And then T is going to stand for time in years. So it always has to be in years. So if you have a problem that gives you the time in months, you are going to have to go out of your way to convert it to years. And like I said, the N is the tricky one here. So depending on the problem, what little keywords in the problem are going to tell you what N to use. So if the problem says that you're going to be compounded annually, that means your N value is going to be 1. Semi-annually represents a 2. Quarterly means 4 times in a year, so N is 4. Monthly, obviously, is every month, so it's 12 times a year. And then daily is going to be represented with the number 365. So we don't take into consideration any leap year, anything like that. It's always going to be 365. So again, this is the formula you're going to use when your problem has one of these words in it. So if the problem says compounded quarterly, that means you're going to use this formula. If it has the word compounded annually, semi-annually, monthly, daily, these are the key words. If the problem has these words in it, you're going to use this formula. Now, the second formula we're going to be talking about today is the continuous compounding formula. This one is a little shorter. This formula, you're going to use it when the problem does not have any of these right here. It has the word continuous. That's the dead giveaway. If the word continuous is in the problem, you're going to use the continuous compounding formula. This one is represented by A equals P e to the RT. So some of my students call it the PERT. This is the PERT formula. And this one again has the same variables. A still represents the money after. P still represents your principal amount. E obviously is just E. It comes in your calculator like that. It's a value. And then R is going to be your rate as a decimal, and T is going to be your time in years. So again, these are the two formulas you are going to have handy. We're going to read the problems, and then we're going to figure out which one we have to use. Like I mentioned earlier, your rate has to be as a decimal. So what we are going to practice real quick is just a super quick reminder of how to convert a percent to a decimal. Because again, some of the problems are going to give you in percent, and you're going to have to convert it to a decimal in order to use the formula. So in case you didn't know, or in case you forgot, or in case you need a refresher, in order to convert a percent to a decimal, there's two different ways to do it. All you have to do is get the percent and divide it by 100, all the time by 100, and voila, it makes into a decimal. If you're too lazy to put it in your calculator, all you could do is also just move the decimal twice to the left, and that'll do the trick. So for example, here we have 25%. It doesn't have a decimal, so when it doesn't have a decimal, it's right here at the end. To convert this into a percent, you could put this in your calculator. So if you want to give it a try, 25 divided by 100, and that gives you the decimal. And like I said, if you don't have a calculator, you could just get the decimal, move it twice to the left, and that also gives you the decimal pertaining to that percent. So again, this is going to be very important, so make sure you give yourself a little refresher, because in all the problems wherein we have the rate as a percent, you are going to have to convert it to a decimal first. All right, so here we go. Let's go ahead and start trying some problems. Here we have the first one. And again, all of these are going to be financial problems where someone wants to invest a certain amount of money and they want to see how much money they're going to have afterwards. So in this one, we have a little scenario, right? You deposit $3,000 in an account earning 4% interest compounded continuously. How much will you have in the account in 5 years? So we want to see if this is an actual good investment. So we're going to do the math and see how much money we would have after 5 years. So again, first thing you want to do is figure out which of the two formulas you're going to use. Like I mentioned earlier, if the word continuously is in the problem, obviously we're going to be using the compounding continuous formula, which is the PERT. Once you identify which equation you're going to use, then you have to start labeling and giving values to the different variables. So in this case, we know that we are starting with an amount of $3,000. So that's going to be my p-value, my principal. We have a rate of 4%, but like I mentioned a bunch of times, right, your percent has to be as a decimal. So I'm just going to do it the lazy way. I'm going to move this 2 times to the left. When there's an empty value, you just fill it in with a 0. So that's how I got my rate of 0.04. Again, if you don't like to do that, you could do it the calculation way. Just go ahead and divide 4 by 100, and that gives you 0.04. So we have already substituted that. Remember, the e is in your calculator. You don't have to substitute anything to the e because it's a constant value. We already have the r. And then the t, since they're asking us how much money will you have after 5 years, then that's my t value. So the t would be 5. And from here, all I have to do is just replace the value. So again, we don't know what a is because that's what we're trying to figure out. I want to know how much money I'm going to have afterwards. So this is my unknown. And then we have 3,000 e raised to the 0.04 and times 5. Okay, so again, it's super simple to substitute the values. Just make sure you do this properly in the calculator. Now, here's the thing. If you want to get the correct answer, you have to put this in the calculator straight how it is. Okay, so you have to be very careful. You cannot round, you cannot do a little piece at a time. You just have to put the whole thing in the calculator. So I went ahead and did that, and I could show you how I did it here. So again, I put the 3,000. Your calculator has this little button with the e raised to the power. If you cannot find that button, let me know. But again, it's in there. So in my graphing calculator, it's actually, I would have to press the second button and then the LN. It's right there. Again, if you can find it, just let me know. And then since this whole thing is an exponent, you have to make sure, if you notice here, it's all has to be in parentheses. So when you raise the e to an exponent, the 0.05 times 5, the 0.04 times 5 has to be in the exponent. So just make sure you put in parentheses, press enter, and look at that. That's my answer. Okay, just one more thing here. Your answers, since they're talking about money, you always have to round to 2 decimal places all the time because monetary values are always representing by cents. So you have to have 2 decimal places. So what I'm going to do here, this is my final answer here. I'm going to chop it off here. Again, that's always going to be the case because when you go to the store, you always have like $5.32, right? You always have 2 cents or 2 decimal values afterwards. So I chop it off here, and then this number is either going to stay or round up. The way you determine that is by looking at the number next to it. If this number is 5 or more, the number here is going to go up by 1. If this number was 4 or less, then the 0 would stay at 0. But in this case, as the 8 is greater than 5, the 0 rounds up to a 1. So this is actually my final answer. So just as a recap, if I go to a bank that is giving you 4% interest compounded continuously, that means that if you start off with $3,000 in 5 years, you're going to have $3,664 with 21 cents. So it's all up to you, right? I think $664 extra is a little good thing for 5 years. But again, that's why people look up at different banking institutions to see which one of them is the best investment option. So that was our first problem. Let's go ahead and try another one here. Very similar. So you deposit $4,000 in an account earning 7% interest compounded monthly. How much will you have in the account in 10 years? So let's see how good this one is. Again, you look for the keywords. The word continuously is nowhere to be found in this problem. So obviously we're not going to use that formula. Again, what gives it away is this right here. Remember when I told you when you have the word quarterly, monthly, daily, semi-annually, all of those are just keywords to tell you that we're going to be using the first formula. So first thing we identify is which formula we're going to be using, which is the normal compounding formula. And then we start giving values to our variables. So in this case, I'm starting with $4,000. So that's going to be the value of P, which is my principal. My rate, again, it's not 7. We have to make it to a decimal. So all I have to do is move the decimal twice, and it becomes 0.07. That's my rate. Now N, if you go back to the previous notes that we wrote down, N has to do with the compounding. Since this one is compounded monthly, my N value is 12. And that goes here and also here. And then they want me to know how much money I'm going to have in 10 years. So that means that T is going to be 10. After I finalize all of that, I just substitute the numbers. Again, A is my unknown because that's what I'm trying to figure out. I want to know how much money I'm going to have after. So all I have to do is just put this in my calculator. So again, you have to be very careful. If you're going to put this in the calculator, this one's a little more tricky because you have to make sure all of this is inside the parentheses, as well as the 12 to the 10 has to be at its own parentheses as an exponent. So this one's going to be very tricky, but this is the way I put it in my calculator. I have the 4,000. And then since this is multiply, you don't have to put any symbol there. I just open parentheses, 1 plus. Anytime you have a fraction, you're going to put an extra set of parentheses. Okay, so hopefully you caught that. I'm going to have 1 plus and then a parentheses for just the fraction. So 0.07 divided by 12. And then I close the parentheses for the fraction. And then I close the parentheses that was originally right here with the 1. Okay, so again, if I confused you there, let me know, but that's what you do. And then raised to the power of, and again, every time you have an exponent, all of that has to be in its own parentheses. So I have 12 times 10. So I know what you're saying. Where did these parentheses go? So when you're multiplying two numbers, you could kind of ignore those parentheses and I just put it times. But as long as the 12 and the 10 are in their own parentheses, then we're okay. Okay, so make sure you're following along with me, trying it in your calculator just to see if you can get the hang of it. Because when you do your own, if you mess up one little parentheses, then yes, you are going to get the incorrect answer. So like I said earlier, you cannot do baby steps. You cannot just worry about the parentheses first and then substitute it. You can't. You have to put the whole thing in the calculator just so your calculation is perfect to the nearest cent. So my answer was 8,038 with 6455, right? But again, like I said, when you're talking about money, you have to chop it off at 2 cents right here. And then you look at this number. Since that number is 5, that means that the number next to it is going to go up by 1. So my final answer is $8,038 with 65 cents. So I think this one was pretty good, right? Just keep in mind that this did take 10 years. So I started with $4,000. I ended up with $8,038. Again, it did take 10 years, but the reason I did make a lot of money here was because we had a good interest rate. Okay, so those are little things that play a role in all of these problems. All right, let's continue practicing here. A bank features a savings account that has an annual percentage rate of 2.7% with interest compounded quarterly. Kim deposits $12,000 into the account. How much money will Kim have in the account in 10 years? So again, fairly similar problem to all the ones we've been doing. We stare at the problem, we try to figure out which equation we're going to use. So again, the word continuously is nowhere in this problem, but this is the keyword that gives it away. So quarterly means we're going to be using the first compound, the compounding formula. So here's my formula that I'm going to be using. And then again, just make sure you assign all the values. So here, Kim is going to start with a total of $12,000. So that is the p-value. The rate is 2.7. Now the decimal's here. So if I move that twice, my rate becomes 0.027, which is right here. And again, if you don't like moving the decimal, just put in your calculator 2.7 divided by 100, you get the same thing. Now the end value is going to be based on this keyword. Quarterly means 4 times a year, so that's going to be 4. And then T represents the 10 years that we want to know how much money Kim will have. So that's that. And again, just like we've been doing with all the other problems, substitute the values. We have the P, open parentheses, 1 plus the R over N raised to the N times T. Be very careful how you put this in the calculator. So I put my 12,000, open parentheses, 1 plus, and like I told you on the last problem, the fraction has to have its own set of parentheses, which it does right here. And then I close the parentheses that were already there, raised to the power of 4 times 10, both the 4 and the 10 inside the parentheses. Press enter, and that's what I got as an answer. Again, if you put this in, you will get it incorrect because when we're talking about money, you have to chop it off here. So I chop it off there. Since this is a 9, that means that the 1 is going to go up 1. So my final answer is $15,705 with 32 cents. All right, so I'm hoping you guys are getting the gist of these. We only have 2 more to go. Okay, let's try this one. If $4,000 is invested at 7% compounded continuously, then how long will it take for the investment to grow to $10,000? Round to the nearest hundredth of a year. Now here is where things start getting interesting, and oh my goodness, I love these problems. So this one is where I turn the tables at you. I tell you how much money you start with, how much money you end up with, but how long will it take for you to wait? That's what we want to find out. So again, let me just read the problem one more time. You start off with $4,000 invested at 7% compounded continuously. And the question is, how long will it take for your account to grow to $10,000? So that's actually something I'm interested in, right? I want to know, is it really worth it? Like, how long will it take for me to have $10,000? So this is very interesting because it's kind of something you want to do, right? Let's say you want to save up for a car, so you want to start with 4,000. How long will it actually take you to end up with 10,000? So let's figure that out. So the word here is continuously, so don't worry, we're going to still use the same formula per. And now here's where things are going to change. I know how much money I'm going to start with, and I actually know how much money I'm going to end up with. So this is the fun part. So let's go ahead and substitute what we know. Principal is 4,000 because that's how much money I start with. In this problem, I actually know the A. I know how much money I want to end up with. So that's going to be 10,000. I know my rate, which is 7%. I moved that twice, giving me 0.07. But in this problem, I do not know T. I don't know how long I'm going to have to wait. So T is my unknown. So before we do anything, let's go ahead and substitute my values. I have 10,000 equals 4,000 e raised to the 0.07 times t. Now, like I told you, these are the fun problems because now we're going to have to solve this problem to find t. Not a big deal because we've been doing some of these in previous sections. So my whole job here is to figure out or to leave the t by itself. So baby steps. We have to get rid of everything here. So first thing I want to do is get rid of the 4,000. Since the 4,000 is in front of the e, they're multiplying. So the opposite of multiplication is division. So I'm going to divide both sides by 4,000. So I'm going to have 10,000 over 4,000 equals, and the 4,000 is gone. I'm left with e raised to the power of 0.07t. Now, since the 10,000 over 4,000 looks very scary, I'm just going to simplify it. So the easiest way to simplify is just canceling zeros out. So I'm just left with a very small fraction, 10 over 4. So 10 over 4 equals e to the 0.07t. Just so you know, 10 over 4 can also simplify to 5 over 2. I didn't do that, but feel free to do that if that makes you feel better. Again, the smaller the fraction, the better. But I'm just going to leave it like this. So 10 over 4 equals e to the 0.07t. Now, this is where you have to use your genius from previous sections. How in the world do I get rid of an e? So I'm going to pretend you said it. Very good. We have to add ln, right? ln is going to cancel with an e. But what I do to one side, I do it to the other. So I added an ln on the right side, but I also have to add it to the left side. So ln of 10 over 4 equals ln of e, and then the exponent. Like I said, those two cancel out, leaving me only with ln of 10 over 4 equals 0.07t. All right, so slowly we're getting there. Now, the last thing I have to do to get rid of this 0.07, I have to divide both sides by 0.07. So that's what I did. So ln of 10 over 4 divided by 0.07 finally leaves me with the t by itself. Now, this does look kind of disgusting, but don't worry, just, oh my goodness, that was meant to be a box. There you go. Okay, that made it worse. So the only thing you have to do here is just put this in the calculator. So I'm going to go ahead and quickly show you how I did it, which is right there. Again, when you have a fraction, make sure it's in its own parentheses. So ln of 10 over 4, close parentheses, and then divided by 0.07. And there we go. So that's 13.0898. Remember, this is time, so this one doesn't have to be rounded to the nearest or to 2 decimal places, but we're still going to do it because that's what the instructions said. So round to the nearest hundredth of a year. So this is your tenths, this is your hundredths. So that means we're still going to chop it off right here. Since this is a 9, this one is going to go up 1. So my final answer is going to be 13.09. Okay, so again, this one was pretty fun because they gave us pretty much all the information, but we had to find the t by ourselves. So we had to use some of that knowledge we learned in previous sections. Now, what does a 13.09 mean? That means that if I start with $4,000, in order to end up with $10,000, I'm going to have to wait a total of 13 years and a little bit more. So I'll leave that up to you. Is it worth it? Is it not worth it? Depends what you're saving for, but that's how you would figure it out and see how long it would take you. All right, let's go ahead and try the last one here for today. If I were you, I'm going to put a big star on this one and I'm going to highlight it and put a little happy face, whatever you want. Just make sure you label, because this example is going to help you for an example that's coming up in your project. So you might not see this problem in your online homework, but trust me, you're going to see it on your project. So just be ready. So again, put a little note, a little post-it or little bookmark on it, just so you can come back to it when you get to your project. So let's go ahead and start this one here. You deposit a total of $1,500 in an account earning 5.3 interest compounded continuously. How much will it take for your investment to double? Round your answer to the nearest tenth of a year. So this is very similar to the last one, but I'm not telling you how much money I want you to end up with. I just tell you I want you to double it. No worries, super simple. So first thing we have to do, like every other single problem, we have to identify which formula we're going to use. So the word continuously pops up, so that means we're going to be using PERT, right? P-E raised to the RT. Now we have to start giving values to the variables. Now, if you look at this problem, there's only 2 numbers. So what in the world we're going to do? Don't freak out. You deposit $1,500, so that's your principal. In an account earning 5.3%, that's my rate. How much time will it take for your investment to double? So if you start with $1,500, how much do you want to end up with? Super simple, you just double that. So if I start with the principal of $1,500, I want to know how much is it going to take for me to double it. So that means I want to have a total of $3,000 after. If you're like, where in the world did she get that? Again, it's just the double of this. So 1,500 times 2. Oh my goodness. There you go, times 2. That's it, that's what you would do. So if this number here would have been 2,000, then your A would have been 4,000. That's it. Okay, so I just wanted to give you this type of problem so you don't freak out when you are expected to do it on your own. And then everything else stays the same. If I move this 2 to the right, 2 to the left, I end up with 0.053, which is my rate. And just like the problem is asking, we don't know for t. We have to find how much will it take. So we're going to have to find the years. Okay, so again, the only reason I threw this one in here is because some people will freak out with this, right? All you have to do is just double your principal. That's going to be the amount you want to have after. Now, substitute it into the formula. 3,000 equals 1,500 e raised to the power of 0.053t. And then we just solve it just like we did on the other one. So first thing we do is divide both sides by this number. So I'm going to have 3,000 divided by 1,500. It's going to cancel from this side, equals e raised to the power that we had there. Now, just like we did on the other side, I don't want to end up or deal with this fraction for the whole problem. So we're going to simplify it. 3,000 divided by 1,500 just gives you 2. So we're just left with 2 equals e raised to the power of 0.053t. Now, what cancels with e? Yes, you're right, ln. So we're just going to add an ln to both sides. So we're going to have ln of e, but of course I also have to do it to the left side, so I'm left with an ln of 2. And just like you said, those cancel out. So I'm just left with ln of 2 equals 0.053t. Now, how do I leave the t by itself? I just divide both sides by that number. So the t is by itself. So I'm going to have t equals ln of 2 divided by 0.053. Up to here, the t is already by itself, so that means I could just put this in my calculator. ln of 2 make sure you close the parentheses because the only number that goes with the ln is the 2. So you close parentheses right here, and then you divide by 0.053. So again, please make sure you're trying that on your own along with the video. So when you do these problems by yourself, you don't make those little tiny mistakes that could give you like the completely wrong answer. So if I put this in the calculator, I end up with this here. Now let me go ahead and read the problem. Round your answer to the nearest tenth of a year. So this is my mistake here. To the nearest tenth is this right here. So that means I'm going to chop it off here. Since this number is greater than 5, that number is going to go up by 1. So please disregard this. Your final answer should be 13.1. Okay, again, because they wanted to the nearest 10. Is right here. And whenever I ask you to round, you always use a number next to it to determine if you're going to leave it as is or if you're going to round up. Since this one, the number next to it was 7, that means the 0 rounds up to a 1, and I really don't care about the 7, the 8, and the 2 anymore. So my final answer for this problem would be 13.1 years.